So to calculate the change in the freezing or boiling point of a solution, the change from the original solvent, we're going to use this formula. And if you're looking at the two formulas, they look almost identical. Delta TV equals IM KB, or delta TF equals IM KF. Did I actually already go through this page with you guys? No? Okay. All right. Same formula, just for the boiling point one, we're going to use the one that has B's in it. And for the freezing point one, we're going to use the one that has F's in it. Okay? So delta TB or delta TF, whichever one you're doing, that's telling us the change in that boiling or freezing point. Okay? I is the number of particles in solution. So if it's an ionic compound, remember we talked about this last time, I know it's been over the weekend, but if it's an ionic compound, those particles, or that compound completely dissociates, remember that word? Dissociates in solution, which means it can break up into its ions. So for example, sodium chloride, NaCl, when it dissolves in water, it breaks up into Na plus and Cl minus. That makes two particles in solution. That's how we're getting two particles. So I would be 2 for NaCl. For CaCl2, it breaks down into Ca plus 2 and 2 chloride ions, so I is 3. Any covalent compound, like sugar, sucrose here, or glucose, or any covalent compound, when it dissolves in water, it stays together as one unit. It doesn't dissociate. So I is 1 for any covalent compound. Okay, so for all covalents, I will be equal to 1. M is molality. We learned how to calculate that last class. That's going to be moles of the solute divided by kilograms of the solvent. And then Kb and Kf are constants that will be given to you. Okay, and it's based, the Kb and Kf is going to be based on the boiling or freezing point, respectively, of the solvent. So it's a constant, but it'll be given. Or you'll be solving for it. You don't need to memorize any of them. Okay? And you don't calculate it from anything else other than if you were solving for it. All right, so let's look through an example. So we've added, in this one, I've taken 45 grams of glucose and I dissolved it in 255 grams of water. I want to know what will be the boiling and freezing point of this solution. Okay? And I give you the Kb and the Kf for water. Okay? So let's tackle the boiling point first. Remember, what happens to boiling point when we dissolve something in water? What happens to the boiling point? It goes up. Remember, boiling point elevation. So that means that the boiling point of this solution should be greater than the boiling point of pure water. What's the boiling point of pure water? 100 degrees Celsius. So the boiling point of this solution will be greater than 100. But we're going to calculate the change to that boiling point first and then add it to 100. Okay? So the formula is delta TB equals IM KB. I is the number of particles that this solute, the thing that's being dissolved, makes in solution. What is my solute? What's being dissolved? Glucose. What type of compound is glucose? It's a covalent compound. What's the formula for glucose? It's C6H12O6. You might remember that from biology. And that, like you already said, is covalent. So what does that make I? 1, because glucose is covalent. So that was easy. M is the molality. We're going to need to calculate the molality of this solution in order to find the change in the boiling and freezing points. Remember, molality is moles of the solute divided by kilograms of the solvent. And our solute is glucose, and our solvent is water. So based on the information given, we need to calculate the moles of glucose and the kilograms of water and then divide them. Okay? So to find the moles of glucose, how do I find that? Mole conversion, because I'm given the grams of glucose, I just need to convert that to moles. So we need the molar mass of glucose. What do you guys get? Molar mass of glucose. (180.18). So we're going to take 45 grams divided by 180.18 to tell us the moles of glucose that we're dissolving in this water. This is not the only calculations we're doing today, so if you haven't already grabbed a calculator, I suggest grabbing one. What do you get? Yeah, 3 sig figs, so 0.250. So that's how many moles of glucose we have. We need to then divide that by what? The kilograms of water, right? Well, I gave you the grams of water, so I need to divide this by, what's 255 grams into kilograms? 0.255. So make sure you review those metric conversions. The most common ones we use are, I think I said this last time, but the most common ones we use are the base unit and then kilo and milli. Make sure you review those three. Those are the ones you're going to see the most often. Okay. So what is that? There we go. 0.980. And that is the molality. Okay. So now we've solved molality. Now I can do, and the great thing about this is the molality is going to be the same for both the boiling point and the freezing point because it's all the same solution. So we did all this work, but we don't have to do it again for the freezing point, depression part. Okay? So now I'm going to plug this into the formula. So delta TB equals I is 1, M is 0.980, and then KB is given in the problem 0.515 degrees Celsius per molal. So notice that molality is going to cancel and we're going to be left with degrees Celsius. So how much is this boiling point going to change by? .515? 0.505? 0.505? You should get 0.505 as the change to the boiling point, and that's in degrees Celsius. So now to find what the new boiling point of, the boiling point of this solution would be, boiling point was what? Elevated or depressed? It was elevated. Boiling point elevation. The solution has a higher boiling point than the pure solvent. This is how much higher? So the pure solvent was what? What boiling point? 100 because it's water. So we're going to add the 0.505 to that. And we could actually test this out. If I added exactly 45 grams of glucose to exactly 255 grams of water, mixed it up, put it on the hot plate, and once it started boiling, if I measured the temperature, I should get right around 100.505. That's not a huge difference, so it might be difficult to actually measure this in the lab, especially in our lab, because we cannot control a lot of the variables. But we could do this. We could just add a whole bunch of solute to see how much it changes that boiling point by. Okay, but it would be increased by a little bit. The more we add, the more it would raise the boiling point. Also, if we change the type of substance we were dissolving, if we change this to sodium chloride, I would end up being 2, which when we multiply it, it would end up increasing that that boiling point even more. Okay? So the more solute you have in solution, the greater the difference in the boiling points and the freezing points. All right, so now we're going to tackle freezing point. So the freezing point formula, delta TF equals IM KF. It's the exact same solution. So I and M are the same because we didn't change our solute. It's still a covalent compound. And M we just calculated to be 0.980. The only thing that's different is the K value because it's talking about the freezing point versus the boiling point. And KF is 1.86. So what do we get as our change to our freezing point? What do you get when you multiply that? 1.82? So our freezing point will change by 1.82 degrees Celsius. So what is the freezing point of water, of pure water? 0 degrees Celsius. This gets changed by that much. Does the freezing point go up or down when you add solute? It goes down. So our original freezing point was 0 degrees Celsius, and we're going to subtract the change from that number. So for boiling point, you add it. For freezing point, you subtract it. So you should get negative 1.82 degrees Celsius as the new freezing point. That's the step that everyone always forgets to do. They calculate the change properly, but then they forget to subtract or add it. Okay? We're not going to do 2 and 3 right now. We'll do that on the review day. I want to move on to the notes that were scheduled for today, so go ahead and turn to page 16. I'm going to stop this video, and then I will record the next topic on another video.